You are welcome to Science Tutorials with Farmeternity the Schoolboy. Today we are going to take a look at chemistry, and the question says 26 grams of hydrated salt of barium when heated to a constant weight gave a residue that weighs 20.5 grams. If the molecular weight of the anhydrous salt is 208, calculate the I number of molecules of water of crystallization in the hydrated salt. II percentage of water of crystallization in the hydrated salt. Okay, let's go. Solution. Now, from this question, actually, this is a case of, converting and heating a salt that has water of crystallization, heating it, and to produce the same salt, but without water of what? Crystallization. Because they say that you heat it to a constant what? Weight. So that means that barium salt will heat it until it loses all the water of what? Crystallization. We don't know the barium salt. We don't know the barium salt. We only know the cationic parts. We don't know the anionic parts of the salt. So if that is the case, we use Y. You can use Y to represent the anionic part. So if that is the case now, we can represent the salt like this. That is the anhydrous salt, the one without water of crystallization. We can represent it like this. We can say, let the salt be what? Let the salt be what? B-A-Y. Barium Y. We don't know this part of the salt. So we call it B-A-Y. Now, this is the anhydrous. Now, let us go to the hydrated form. All we know is that hydrated form of a salt should have water of crystallization. But we don't know the number of moles or molecules of water of crystallization that it will contain. So if that is the case now, we use X to represent the number of molecules. So that means the hydrated salt will now become something like this. BAY dot X water. So this is the what? The anhydrous salt, and this is the what? Hydrated form of the salt. Now, we are told that the weight of the hydrated salt is 226 grams. So weight of BAY dot is what? 26 what? Gram. Then if it was heated to a constant weight, so for the weight to be constant, that means it has lost the water of crystallization. So what remains is BAY. So the weight of BAY produced is what? Weight of BAY is what? 20.5 what? Gram. 20.5 what? Gram. Now let's continue. Now, what is the molecular weight of this anhydrous salt, BAY? Molecular weight of BAY is what? 208. 208. While the molecular weight of the hydrated salt, we need to calculate it. Hydrated salt contains the anhydrous plus water of crystallization. We already know the molecular weight of BAY, but we need to calculate the molecular weight of the water of crystallization. Then add it to the molecular weight of this BAY before we can get the molecular weight of BAY water of S water of what? Crystallization. So molecular weights of BAY dot X water is equal to what? Molecular weights of BAY plus molecular weight of BAY plus molecular weight of what? Of the water of what? Crystallization. So let's calculate, we know this one, so let's calculate this one. Molecular weight of this will give us this. So X mole of water of crystallization contains 2 moles of hydrogen atom. 2 moles of hydrogen atom plus 1 mole of oxygen atom. 1 mole of oxygen atom. Now, if that's the case now, X is still there. This now we use the relative atomic mass of hydrogen to represent here. Remember, they gave us is 1. So this will now become what? 2 times 1. That of oxygen is 16, which is what? 16. So this now becomes what? X. This is 2 plus 1 times 16 is what? 16. So this is this now becomes X. 2 plus 16 is 18. So this is now X into 18. So we bring it up here. X into what? 18, which is what? 18x. Which is what? 18 what? X. 18x. So the molecular weight of the water of crystallization is what? 18x. While the molecular weight of the BAY is 208. So that means the molecular weight of the anhydrated salt is now molecular weight of the hydrated salt is now equal to what? 208 plus what? 18x. This is the molecular weight of the what? Of the what? Of the hydrated salt. This everything should be in gram anyway. This is also in gram. Even though it wasn't specified, but that now we are not dealing with mass, so it's in gram. Now with this now, let's go. So we have established 4 things. We have established the molecular weights. We have established the weight of the hydrated salt to be what? 26 gram. Molecular weight of the hydrated salt to be what? 208 plus 18 s, all in gram. Then the molecular weight of the anhydrous salt is what? 20.5 gram. Then the molecular weight of the anhydrous is what? 208 what? Gram. Now with this now, this is what we have established. This is what we have done what? Established. So now let's go. I can now clean here. Now, remember on heating, see what happened on heating. BAY dot X water when heated we result to what? This water we lost. So this is what we produced. So that means initially 26 gram of this produced what? 20.5 gram of this. 26 gram of this produced 20.5 gram of this. Therefore, the molecular weight of this, the molecular weight of this 208 plus 18x will also give us this same value, 208. So at this point now we cross multiply. We cross multiply. If we cross multiply, we arrive at something like this. 208 plus 18x times this 20.5 gram is equal to what? 26 gram times 208 what? Gram. Our target is to find this x. So we are going to make this x here. We are going to make this x the subject of the formula. So let's continue from here. So we divide both sides by 20.5 gram. We have 208 plus 18x is equal to what? 26 gram times what? 208 all over 20.5 what? Gram. So if that is the case now, we now have that this, if we cancel this thing out, we end up getting something like this. This times this over this. This will give us 20. This will now become 208. 208 plus 18x is now equal to what? 263.8 gram. This is what this gives us, because 1 gram, we cancel 1 gram here. And if you multiply this, if you punch a calculator, it will give us 263.8 gram approximately. Now, at this level now, remember, at this level, our target is to make this x subject of the what? Formula. Our target is to make this x subject of the what? Formula. So this will now give us what? That 18x is now equal to 263.8 gram minus what? 208. Remember this 208 is also in what? Gram. Now, if that is the case, we now have that 18x is equal to 263.8 gram minus 208. This will give us around 55.8 gram. 55.8 gram. 55.8. Remember, this whole thing is also in gram. Remember, everything here is also in gram. Okay, because if this multiply this, it will take the gram. So let's continue. I'm trying to, so that means 18 gram, 18x gram is equal to 55.8 gram. No, in that case, we now have that. What happens? We want to make x the sort of formula. So let's continue. This now becomes what? That x is now equal to what? 55.8 gram. You divide both sides by 18 gram over what? 18 gram. And this will give us 3. If you punch the calculator, this will give us around 3.1. 3.1, because gram cancel gram. 3.1, which is approximately what? 3. X is what? 3. So if x is 3, that means that the number of molecule of water of crystallization in the hydrated salt is what? 3. So that means the hydrated salt will take this formula. That means the hydrated salt will now take this formula. B plus what? This is the formula of the what? Hydrated salt. Now, let's continue. Let's go to the II part of the question. II part of the question says, that we should calculate the percentage of water of crystallization. Now, from the question, this one is simple. Percentage of what, initially it had a weight of 26 gram. You heated it, the weight changed to 20.5 gram. Water of crystallization was lost. Now, what is the weight of that water of crystallization that was lost? That is what we use to determine the percentage of what? water of crystallization that initially contained in the what? Hydrated salt. Now, percentage water of crystallization is equal to weight of water of what? Crystallization over what? Weight of the hydrated salt. Weight of the what? Hydrated salt times what? 100%. So this is the formula we use to determine the weight of the percentage water of crystallization. Let's start with the weight of the water of crystallization. Weight of water of crystallization is the difference in weight. So that weight of water of crystallization is equal to weight of the hydrated salt minus weight of the, this is too far. Is equal to weight is equal to what? Weight of the what? Hydrated salt minus weight of the what? Residue. Yes, residue or the anhydrous. Remember, the weight of the hydrated salt is 26 grams. So 26 grams minus weight of residue is what? 20.5 grams. This will give us 5.5 grams. So the weight of the water of crystallization is 5.5 grams. Now, we already know the weight of the hydrated salt to be what? 26 grams. That means weight of water of crystallization. That means weight of water of crystallization is now equal to what? 5.5 grams over what? 26 grams times what? 100%. If you punch the calculator properly, this will give us 21.15%. So the percentage of the water of crystallization in hydrated salt is what? 21.15%. Thank you very much for your attention. Please, if you have any question, feel free to chat me up on WhatsApp. My WhatsApp line is on the screen. To watch our lectures and other entertaining videos, please subscribe to our YouTube channels. We have 3 YouTube channels. The first one is our YouTube channel dedicated for academic videos, for lectures only, and that is Susan Academy. The second one is our general comping WhatsApp comping YouTube channel. There you see a lot of interesting videos, not only academics. The name is Susan Limited. You can also subscribe to my personal YouTube channel. The name is From Eternity, the Schoolboy. My name is From Eternity, the Schoolboy. See you next time.